Hi everyone, and welcome to the second AMA session of the Encode Club MultiversX hackathon. So exciting to see all of you here. And today we are going to be talking about smart contracts. So any questions that you have on that topic, feel free to pop it in the chat, or you can also post it in the sort of question form, and I will flag it to the people who I'm going to invite to the stage right now. How are you?
Fine. Eager to start the second AMA, and I'm curious to see what questions our developers have or hackers.
Yeah. Hopefully, some of you guys have had the chance to look at some of the workshops that were released today, and can kind of spin off of that in terms of follow-up questions. I'm just going through now and inviting everyone to stage. Hi, Robert.
Hi, everyone.
Hello, everyone. Can you hear me okay?
Yep.
Yeah,
Hello,
all
Andrei.
good.
Oh,
Hey, Lucas. Thank you for joining our second AMA session. Our main theme for today are smart contracts. So last time we discussed about blockchain basics and about SDKs in general. Today we are going to discuss about smart contracts. I want to express my gratitude to each of you for not only being here today, but for also participating in our previous AMA. It was a nice session. Basically, we are targeting to make today's session just as engaging and informative as the last one. It's a very great thing that it's recorded, so anybody can watch it again later or whenever needed. Before diving into today's discussion, I want to remind you that we've published the pre-recorded workshops in the Developer Resources channel on Discord under the Hackathons category. Later today, we will also have all those resources published on the Hackathons webpage, where we will also add links to our documentation, builders forum, faucets, wallets, APIs, and so on. Those resources are there to support you in the hackathon, but not only. And to be honest, we really appreciate any feedback on them. So not only on the links or documentation, but also on the pre-recorded workshops. Your input is valuable to us. So share your thoughts, come with suggestions, and any other comments that you may have. For today's AMA, so before starting, I would like to introduce my colleagues. I will ask each of him to describe a little himself and provide some insights about the workshop that they created and probably about their backgrounds. So Andrei Marnica, can you start?
Hello, everyone. My name is Andrei Marnica. I am a developer at MultiversX. I am the main. I started out the smart contract framework. I've also contributed to the VM. I also built a lot of the tools that maybe some of you are using for testing. I'm pretty much everywhere. So you can ask me anything about smart contract development. I'll be glad to answer any of them.
Great. Thank you very much, Andrei. Robert, hello, and thanks for joining today.
Hi, everyone. Again, I am Robert Sasu, one of the core developers working on VM, ESDTs, processing, and a bunch of stuff regarding DeFi.
Thank you. Aline, I think Aline will also join us a little bit later, probably, Aline Cruciat. But until then, Lucas, hello and welcome.
Hi, everybody. So I'm Lucas. I'm from X Exchange team. I work in X Exchange team. And also I've co-founded the ARDA. And the workshop we have published is about X Suite. It's a JavaScript library that helps you to initialize, build, test, and deploy smart contracts very quickly. And if you have at the time to watch the workshop or have any question regarding it, it will be a pleasure for me to answer.
Great, thank you. And Alin joined. Hello, Alin.
Hello, everyone. I'm Alin Cruciat. I'm a developer, mostly working on the framework together with Andrei Marinica. And I also have a few tasks with smart contract development. So I'll be assisting with anything you need. I also made the small tutorial with developing this crypto zombies tutorial. So yeah, I'll be answering you questions about smart contract development today.
Thank you very much. And Andrei Bonciu also joined. He participated in last Friday's AMA as well on SDK side. But given the fact that last time lots of questions came on the smart contract topic, we thought that probably today some questions will be about SDKs. So that's why we thought that maybe Andrei joining would make sense. Andrei?
Hello everyone. Indeed, I'm here to ask any questions you have about the interaction SDKs, especially the JavaScript and the Python one. Yeah.
Great. So please feel free to ask your questions in the chat window. We'll do our best to provide you with valuable insights and responses. And before I see that we have some questions before starting, kind reminder that your feedback and suggestions are very important. All your questions here may help others back home when watching the recorded video. Yeah. And also, please let us know what other workshops you'd like to see in the future. Thanks. Let's see. Should we start?
Yeah, sure. I've actually gotten a few questions already come in, if you don't mind going through those first.
Sure.
Yeah. Okay, so the first question is it possible to send raw transaction from contract?
Yes, it's quite possible. You can send whatever you want from a contract. You can use the transfer and execute endpoint or the transfer ESDT and the execute endpoint, and will do whatever you choose. This thing is abstracted from the framework side, so you don't have to choose one of those two endpoints, and you can send or call whatever you want in any shard.
A bit more context on that. So we have this contract call system that we're trying to use to encourage developers to call other smart contracts in a very type-safe way. So very high-level calls. But of course, we also provide the low-level API. The rule usually when you're building a framework is that you always want to have also the low-level stuff available to developers, not just the high-level stuff. There's a video that's just come out today, and it also includes a bit of that. So hopefully it'll help.
Thank you. So I see that M also asked, is it the send raw function in Rust framework?
Yes. So at some point we split them. We wanted for it to be very clear what the lower level functionality is and what the higher level functionality is. So in general, everything under send raw is sort of the more basic stuff. Fewer types, you can build your transaction yourself. And everything that is in send is generally a bit higher level. And actually, the functionality in send always goes through this functionality in send raw. So everything goes through there. If you choose to work with send raw, you're basically closer to the source.
Thank you.
Another question I had was, what are storage mappers? What's the difference between them and storage keyword in Ethereum Solidity?
Yes, I'll take that too. So the idea is as follows. The storage on both on Ethereum and on MultiversX is a very raw thing. So keys are just raw values and values are raw values. So there's no types, there's no integrated system for managing keys. Everything we do to add structure to this is added on top. And of course, as builders of a framework, we are trying to offer our developers a way to work in a very structured way with the storage. And the way we started was to just offer storage get and storage set functionality. So let's take it from the rawest, the most basic, to the highest level. So the most basic would be, okay, you read from storage and you write to storage, and you deserialize and serialize yourself. That's obviously not ideal. Then we build on top the storage get and storage set, in which we offered integrated serialization, so both for the keys and for the values. So you could basically read and write with any key you wanted and any type of supported value that you wanted. But soon we discovered that it was still not enough for developers, so we added another layer on top. We added these objects, which are called storage mappers, which are an integrated way to work with multiple keys. Now, of course, if you have a single cell, a single location in storage, and it's the same, like calling get or set on it, or having a single value storage mapper is pretty much the same. But as soon as you start working with lists or maps or unordered sets, all kinds of these structures that you want to spread out over several storage cells, it becomes more difficult. And we discovered that a lot of the code in the early smart contracts would have been just re-implementing again and again this functionality for handling storage. So we decided to make a more systematized and more concise way of working as a developer with this storage. And that's how the storage mappers were born. Now, in their current incarnation, storage mappers are basically glorified key handlers. So all the contents that they hold in the storage mapper object is mostly like the key and how the values map to the storage. And what I also want to mention is that we have plans for this autumn, winter, to design an even better storage system. We get a lot of this question: why are storage mappers allowed to overwrite? It's very simple, because we didn't get to implement a proper system where we forbid this kind of overlap. But such a system will come soon, and this is not the only feature that's missing. It's the feature that people observe most. There's much more to be added to storage mappers in regards to their safety, in regards to their composability. So we have pretty big plans to build an even much better system. I hope you'll all love it. We just haven't had time to start implementing it. So I suspect around xDay or after xDay, you will hear. At the very least, we'll start development very actively then, and you'll have I hope in 2 months, you'll have something new. So that's the big story with the storage mappers. In an ideal world, it shouldn't matter that the storage mapper is in storage. It should be this kind of thing that it could be in memory, it could be in storage. You wouldn't care so much. You would only care about the data layout and the algorithm. That's what we want. We want developers to only care about the business logic and not worry so much about data representation and stuff like that. Oh, and another part of the question was how this relates to Ethereum. Ethereum. So on Ethereum, every smart contract is like a big storage mapper. Every time you declare storage in Ethereum, it's like a big storage mapper. Basically, Ethereum translates this in EVM directly into, okay, this is a single value, this is a list, and so on. So in a way, they were inspired by what EVM does, but in Rust, we had to implement it maybe a bit more explicitly. We did not have access like that to the language. We couldn't just handle them like regular variables, because that would have mean to change the Rust compiler or something. So we had to create these objects. But in spirit, they are akin. I hope this answers it.
Thank you. Yeah, I'm sure that was really, really helpful. And kind of as a follow-up question on that, the person also asked, why can storage mappers overlap? Is it possible to have multiple readers from one memory place and decode this memory into different types?
Yeah, so that's what I answered a bit earlier. So they can overlap. Because we didn't get to implement something better yet. And we've actually also waited a little bit because we want to have this second generation of storage mappers, which have a lot more features, including this protection from overlap. Yeah, and I mean, there's two ways you can implement it. You can implement it sort of in a meta programming way. When you compile the contract, you could have a algorithm that goes through the storage declarations and checks. But there's an even better way, I think, by using the Rust borrow checker to check that they don't overlap. You can actually do this, I think, and we're gonna try a bit of both. But again, this is something that is coming. We've had it on our plates for a long time, and I know the community wants it. So it's definitely going to be there, hopefully before the end of the year, with everything tested and all.
Great. I'm sure that will be very exciting to everyone in the community. Okay. It's also been asked how to buy gas. Should it be bought manually or is it an automatic operation? Is it possible to convert gas into a gold?
I don't necessarily get the question, but for any blockchain-based system, the one who sends the transaction has to pay for the transaction for the whole processing. So that one has to own EGLD and process. And that EGLD, the gas needed for that transaction is deducted from their EGLD balance. However, if you want to pay for your users' transactions, then you can use the relay transactions, which means that you wrap, the user makes you a complete transaction, and then you wrap that transaction into a relayed one and post it on the chain. The chain will verify signature and will verify nonce and everything for both of the transactions, the relayed and the inner one. And it means that the relayer is paying for the user for his transaction. But again, payment is in EGLD, so the relayer has to own EGLD. One of the things we are coming up now, and it will be a new smart contract, it's a paymaster functionality in which what you can do actually is that enable users to use ESDT tokens to pay for whatever operation they want, and the operation will happen atomically. This means that the user will call the paymaster smart contract and will say that, okay, forward me this kind of execution, and the paymaster smart contract will forward, execute, and send the results to the user. And the first payment of the user transaction will be used for paying the relayer. This means that if you make a multi-ESDT NFT transfer, the first payment out of it will be for the relayer, and the rest will be for the forward execution the user wants. So a good relayer service has to be built up, which takes the payment from the first ESDT and then executes everything else. The user is safe, and the relayer has some funds in order to process millions of transactions for that user.
I think this is a follow-up question to what you just explained about the relay transactions. But how do the relay transactions affect the sorting algorithm form intra-shard transactions? What address is taken into account, relayer or the relayed one?
It is taken, the relayer address is taken into account, but as the sorting is randomized, it doesn't really matter. So I don't see any, as we are protecting from MEV, minor extracted value, From the protocol level, it really doesn't matter what kind of address is sending because the sorting is done through a randomness.
Yeah, thanks. So, next question. On what stage init is called? Is it called automatically or should it be called manually? If it is called automatically, can it be postponed and called manually?
The short answer for the third one is no. Init is called only when the smart contract is created, or init is called when the smart contract is upgraded. But the second part of my answer will go on through only for the next few weeks until RC 1.6 is launched on the mainnet. There, if in case you upgrade the smart contract, the upgrade function is called, not the init function. So the init function will be called only once when you deploy your smart contract.
Oh, and also one thing to mention, you cannot call it by manually. So it's not actually possible to call it. The protocol will not allow you to call it manually. So if you send a transaction with a string in it to call the function in it, you cannot do that. It will crash.
Thank you for the answers. Next one. Is it possible to declare method which will be called on funds receiving?
It is not possible. I know Ethereum has something like this, has a specialized method that you can sometimes trigger, but we don't have that. We don't support that. The problem is it can lead to certain vulnerabilities. So it can cause certain transactions to fail, and you can then exploit in certain ways the protocol. So we
actually, Ethereum,
we can.
No, actually, Ethereum doesn't have something like this, but as you have a few token standards like ERC20, ERC21, ERC1155, everyone knows that they have to call transfer from function. So
I would add a very small thing on this, is that on MultiversX, you can make the smart contract non-payable. And so you can force the person to call an endpoint. And this way, you can force the person to call your endpoint in order to send you some tokens. And then you can decide to execute some logic in the endpoint. So I would say that there is not a way to trigger some logic when somebody sends you tokens, but you can prevent the person to send you a token and force the person to call an endpoint. So I would say there is a solution on MultiversX for this. It's just not exactly the one you expect.
Thank you.
The good thing about the way we've chosen to do things is that when you only send like eGold or just an ESDT token, you can be sure that the gas is not, you don't have surprises with the gas. So an eGold transfer is just an eGold transfer. An ESDT transfer is just an ESDT transfer. If you choose to also call a smart contract function after that, then you're aware that there will be logic coming after it and you can adjust your gas. If we had smart contracts, add extra logic just for receiving eGold or ESDTs, then you would have never known if the gas will actually be enough for a simple token transfer. And we didn't want that. So yeah, that is the way, like Luca said, to do it. You force people to go to one of your endpoints. And also the nice thing is that these endpoints have names. Maybe you have several, maybe give some options to the ones who send you tokens. And then the process is a bit more transparent. There's a bit less of a magic factor to it. So, and we don't like too much magic on the blockchain. Yeah.
Thank you very much. We'll take the next one from Will. He said, as far as I know, there is no integrated way to make a contract send transactions automatically. Is there any plan in the future to allow for scheduled transactions on smart contracts? And then he added, schedule a transaction to be executed by the contract at a certain timestamp.
You know, the blockchain as the space is a reactive one. This means that it has to react on some kind of input. And this kind of reactions means that you have to trigger these kind of executions. That's That's true for the whole space. What I do suggest is that you do a cron job, and that will be trigger for at executed timestamp right now. This is what you can do. Although this doesn't mean that we will, let's say, not go into the in the future into researching some kind of things. But right now, the blockchain paradigm is a one, which is a reactive one. So it makes execution upon triggers, and this trigger is a transaction. So you can overcome it by running a cron job, which will execute you something.
And just something I want to add, maybe you, the person who's asked this, maybe you've seen in our announcements the term scheduled transaction and thought it's a way of scheduling transactions in the future. It's not. It's a misnomer. People interpret it as something it's not. So we do have a thing in the protocol called scheduled transactions, but it's nothing of the sort. It's just a way of executing more transactions in a shorter amount of time. It's not about scheduling transactions in the future. Is about how the validators organize transactions and how they execute them. It's not like a cron job. So like Robert said, if you want a cron job like that, you should set it up off chain and maybe have an account that sends these transactions periodically, but they will have to be triggered off chain. And it's actually not so far-fetched. Some oracles do this, so it's conceivable that you have an oracle and then you have a job, and the account that is controlling the oracle periodically sends transactions, but you have to do it like deliberately off chain. You can't. Yeah, that's the answer, I think.
Thank you very much. Then we have Daniel. How would you approach this scenario? A system where users can send or receive tokens via smart contract. Do we actually need an additional database for the user management, or can it be fulfilled by the sole smart contracts?
Can we elaborate a little bit more in this kind of
it's a bit
question?
We don't really know what Daniel what you want, what you're looking for. In principle, you can have an account of what you want to send, what you want to receive in the smart contract. Now, even though so let's say you have a smart contract that does all the management by itself, you will still probably going to also have a database that replicates that data off chain just for performance reasons. So your users will not interrogate directly in your dApp, interrogate directly the VM and the smart contract. You will have a database that gets indexed periodically, and it scales a bit better for many requests. So in that sense, most dApps have some state that is managed by a smart contract, but also some state managed in an external database for this reason. You will have to provide us with more details on what you want to achieve. So,
yeah, that will help. And then from Doinel, we have a series of 9 questions.
I've been looking over them, and I think I can answer. Probably the person that looked over this already looked on my tutorial of how to make a smart contract part 2. In order to simplify what you wanted to ask, imagine a proxy that's some kind of a shadow of another contract that is already deployed on the blockchain. What you want to do is to interact with one or several of its endpoints. What you want to do exactly is to try to mimic how the contract looks like, so that afterwards you can interact with its endpoint. The callback is not necessarily related to the proxy, but more is related to the async call. Once you make a call to another contract, since you have no idea if the call will go through or not, you will have a callback. This callback will just receive the response once the call to the other contract is finished, and will give you as a result some elements, what the endpoint returns, if it succeeded, or an error. From this, in the callback, you mostly just interpret the result, and after that, do some further operations. For example, setting the mappers, just pointing out that the call went through or whatever else you need. I don't know if I answered your question or not.
There's more about this in the videos that came out today. So
Yeah,
I'm really
yeah.
talking there about proxies, callbacks, events, and many other things. So maybe also check that out.
Yeah, check that out before. Yeah, would help a lot.
I'll just share a link here to the post and also to the website in a second. Here it is. Great. So I see there are no new questions. Is there something that you guys want to add? Or is there something important that you think our hackers should be aware of?
Oh yeah, so somebody asked about Bech32 encoding. A bit of context for that. So Bech32 encoding is really nice for users, for the front end usually. It's the encoding that you see in the Explorer too. But it doesn't show up that much on the blockchain itself, and the contracts definitely do not work with the Bech32 encoding. They work with the hex encoding, which is 32 the 32 bytes representation of an address. Usually what you want to only have the hex version in your smart contracts, because the Bech32 tends to be a bit expensive if you try to run it on a blockchain. That's why we did not provide the functionality for Bech32 in the smart contracts. So you don't want to use Bech32 anywhere in the smart contracts. You usually want to use on a dApp and off-chain and leave just the hex representation of addresses in the smart contract. That's a bit about that.
Okay.
And
there is Jeremiah Noah asking, is the smart contract also written in Solidity? Probably, can a smart contract be also written in Solidity? Is the chain EVM compatible?
The short answer
right now
is not, but we have so much more going on MultiversX that we will forget about Solidity pretty fast. Our VM is much faster, like 100x faster, much safer through the token standards. And you have much more types of interactions which you can do between smart contracts to smart contract calls. Also, you don't have issues like reentrancy issues, and you do not have to know about, like, when you want to integrate a token, you do not have to know about what kind of smart contract create that token. You just can easily integrate anything through token IDs. So your smart contract will be like easier to code for anything you want for DeFi. Whenever you launch a token, you do not have to, for example, to make any concessions. And in case of NFTs, you can list your NFTs in multiple NFT marketplaces without, in case, for example, in OpenSea, you are somewhat obliged to launch on only one platform. Here you can do in multiple ones. So you have a lot of new things, exciting things on MultiversX, which can be, let's say, great. And you will find a new word here, which is scalable, safer, and you can build it easier. So it is relatively easy to build smart contracts on MultiversX.
And also maybe Rust might look like a bit more complex than Solidity, but at the end of the day, personally, I find it easier to write contracts in Rust because it's a language that is way more developed with tooling that is way better, etc. So when all this comes together, I think experience is easier. And also, Robert said that writing smart contracts is easier. I agree on this. And also, understanding the contracts is also easier. For example, the concept of ESDT, token on MultiversX is way simpler than on Ethereum. On Ethereum, it is the tokens are contracts, and in practice, you need to check the code of each token you are interacting with because there could be surprises in them. So, I mean, the paradigms in MultiversX are way simpler to understand also. So it's worth it. And one thing important to say that Robert said also a little bit is that for a lot of things on MultiversX, you don't even need to write a smart contract. For example, if you want to create a collection of NFT or a token or etc., you don't even need to write a smart contract. Whereas on Ethereum, you need to write a smart contract, make it audited, etc. On MultiversX, it's just in the UI, in the web wallet, you can just go click on a few buttons and pay for the gas, and it's done. You have your token already created. So yeah, it was my 2 cents on the development of smart contract on MultiversX.
And to give you another small example, just imagine how much of a headache you have to make in Solidity an endpoint to be only callable by the owner. In Rust, you do it by only one small annotation.
I'll also add my 2 cents because everyone has an opinion on Solidity. For us, actually, the big deal breaker for us, because we did consider adding Solidity at some point, but the big deal breaker, there's actually 2 big deal breakers, but the biggest one is sharding. We were one of the first sharded blockchains out there. Ethereum is just experimenting with sharding right now. And the truth is that Solidity has no solution for sharding right now. So whenever you have 2 contracts in different shards interacting with one another, you don't have anything like that in Solidity. So we said instead of extending Solidity and having to deal with all of that, let's just build something better from the base up. So that's the thing. So that's one of the things, and the other one is of course the tokens. So that my colleagues mentioned them, but the tokens are also, the way we've implemented tokens is also a response to the idea of sharding. It's very difficult to have tokens as contracts if you're in a sharded environment, because then the token will be in one shard because contracts are only in one shard, and you would have to
You are
here, Andre? Yeah. You're on mute. Yeah.
Yeah. We cannot hear you.
sorry, just
No, it's cool. We can hear you.
Yeah, so I was saying the tokens are also a response to sharding, because tokens, the way we've implemented them in the protocol, they're easy to transfer between shards because they're native. So, and that's also something that Solidity does not support. Will we also have will we offer at some point some Solidity support and some EVM support? Maybe. So stay tuned for that, but I can't promise anything. Our hope is, I mean, very few people ask us when will we have Rust and WebAssembly on Ethereum. That's, I think, a much better question.
Great. There is one question coming from Daniel. We are also looking to participate in the hackathon, and we were wondering if the form that we completed is enough to be registered. The short answer is yes, but probably Clara can provide more insight into that.
Yeah, so basically the form that you've registered is everything that you need to do, basically. But then as soon as you've registered, or a short while after, you should be sent an onboarding email with more information of like which Discord servers to join and where you can find all the developer resources, etc. So unless you've received one of those onboarding emails with all that information, just send me a message, let me know. You can even write here in the chat, and I'll make sure you get all that information sent to you ASAP.
Great. Yeah, so for today's session, anyhow, we planned for 45 minutes. So we have 5 minutes left. You have 5 minutes left to ask any kind of question related to smart contracts you have. Until then, Lucas, is there something that you want to add about X Suite?
About X Suite, it's a library that might be convenient to people who have experience using JavaScript. It has two things: a CLI. So basically, in your terminal, you will be able to use it and execute commands, and especially create a new contract, create a new wallet, claim fake GLD for this wallet, deploy your contract, build your contract, test your contract, etc. And then there is the terminal thing, and then the JavaScript library that allows you to test your contract and deploy your contract very easily using a Simulnet that we call. It's a wrapper around the VM that exposes the same API as the real blockchain. So basically on your computer, it's basically the same logic as Mandos or Scenarios Executor made by Andre, but just exposes this as an API. So in your code, you will be able to call this API and run your tests. And with the same code, not only you will be able also to call the real blockchain and deploy your contracts. So you can only write your code once or learn one paradigm and be able to deploy and test your contracts. So, and if you have any question, feel free to reach me out on Telegram at Lucas Willems, and we can have a short one-on-one for personal training or anything that will be helpful.
Thank you very much, Lucas. Aline, is there something that you want to add about the other two parts from the Crypto Zombies tutorials?
I can say that the Crypto Zombie will get a few updates in the following time. But yeah, the next two parts will be released very soon, also on video, talking a bit about refactorization, how to keep your code clean, and some more elements such as payable endpoints and only owner. Yeah, so stay tuned about it.
Thanks. I see that Jeremiah came with a new question. So himself and a friend on the hackathon are looking to building a tool, but they would but the tool would be cross-chain, a dev tool. So basically what he's asking is chains that allows contracts written in Rust can be said to be compatible with MultiversX.
I wouldn't say true to this, because every chain has its own, let's say, API, blockchain hooks, through which you are getting the information out of the blockchain or how you write storage. It depends on whether you are coming from other chains like Near, or Near is one of the examples with Rust, or actually you would have to somehow rewrite a few things of your contracts through wrappers or not.
Coming from other blockchains to MultiversX, I know a team who tried it. It can be a bit tricky because you have we have a few extra features that other VMs do not have. But the other way around, starting on MultiversX and then trying to export stuff on Near or other blockchains, that might actually work. I have a few ideas how it would be possible. So if you want to try something out, I can tell you a few ideas. For instance, we have managed types. Managed types are types managed by the framework, but if you tweak the API in a certain way, you could still manage them in memory. So you could write a smart contract in a syntax similar to what we do on MultiversX, and then I think you could conceivably like compile for a different chain. I haven't tried it. I don't know how different other chains are. Maybe if they have some other interesting features or something we don't have, maybe it would be more difficult. But in principle, if you start with our framework and then try to replace the API. So our framework has this very nice syntax and all this meta stuff and features and build system, but it's has everything related to the VM and to the WebAssembly layer completely abstracted. So if you try to go there and change that, then you might actually be able to compile some contracts with our framework on other contracts or on other platforms. If you're interested in that, write me. We can exchange some ideas. I think it would be an interesting project to do for sure.
Thank you, Andrei. I see that there's still some insight needed from Daniel. So Daniel, please go to Discord and write in private to me. I will also add Robert to our discussion, and let's see if we are going to understand better what's your use case. In the meantime, Sagar Jeti asked that, what about the learning curve on MultiversX? How many days?
I would say that the learning curve relies more on learning Rust than learning to make a smart contract in MultiversX, because once you know how to code in Rust, making a smart contract is just having a few more annotations, a few more macro calls over the basic Rust syntax, and you're just there.
And I also have to mention, you don't have to learn all of Rust to code the smart contract. There's a few features of Rust that you have to understand, like ownership, because everything in Rust every Rust developer needs to understand ownership. But there's a lot of really tricky Rust stuff that you really don't have to go into. The framework provides, the basics for the most part. You shouldn't be too difficult.
And regarding ownership, I would say you need to understand it if you want to be sure you are coding your smart contract correctly, but it's not even necessary to start. You can, my personal way of learning new things and learning fast is just to start building. I don't care if I have very good understanding or not. I just try to quickly do things and ship, etc., and test it, and etc., and then I try to learn and improve and iterate a lot on this. So I'm just saying, if Rust scares you a bit, never mind. Just start by doing a smart contract, publish it, put it on DevNet, and test it, learn from it, etc. And when you feel confident, etc., you will put it on mainnet later on. But you don't need to have perfect understanding to start building and start putting something on DevNet.
Like even the ownership, you might just have to write clone a few more times. Maybe you would never think about this in another language, but in Rust, sometimes you have to write clone, sometimes just like an ampersand, like a reference or something like that. It's no biggie. I mean, maybe it's not perfectly optimal from the first version that you release, but it's fine. It works. And you also have the testing tools and all that. So that's actually, and it's actually something that I think a lot of developers don't understand. The tricky part about building an application is not building the code itself. Usually smart contracts will be small. The big part is writing good testing, is the stuff you write around the smart contract. So that's why we also did not worry so much about, Solidity versus Rust versus other programming languages. Those are not so important because you're ultimately not going to spend that much time writing the code. You will hopefully spend 10 times as much time testing your application and making sure everything runs absolutely perfectly, because we're on the blockchain. There's a lot of money there. You should be testing really well. So as long as you do that, you'll be fine with the contract.
And in terms of writing your code, don't forget that Cargo Clippy is one of your best friends. He always tells you everything you're doing. If you're doing something wrong, you'll not get rid of him. We also have nightmares with him.
All of us, we all learned a lot from Clippy. Clippy not only tells you what you did wrong, it also tells you how to fix it. So you get a lot of good practices out of it. It's a great linter, one of the best out there. So, yeah.
Great. So from Sagar,
can you go through Journey Library Full Stack MultiversX? I think we don't have time for that, but maybe go through our videos that we're releasing today, and I hope at least part of the stack will be covered. But it's gonna take a bit of while to go through all of it. It's a lot to talk about, but yeah.
Oh, that would be for today. Any other question that you may have, please join us on Discord. Ask your questions there. You can go to dev support forum, or you can directly ask your question in the Future of Technology channel. Wherever works for you, we are there. It's very important for you to provide some feedback also on the workshops that we released today. It's very important to understand if other workshops are needed from our side. And also any feedback regarding documentation and also other tutorials that we published in the past are quite some valuable inputs for us. Thank you very much, Robert, Andrei, Lucas, Andrei, Aline, Clara, and have a nice evening and see you on Wednesday.
Bye.
Bye, guys.
See ya.
Bye.
And keep building. See you at the hackathon.
Yeah, exactly.